Good afternoon all. It's our privilege to have an eminent resource person, Dr.Thimmaraja Yadav ji, for today's session. Dr.Thimmaraja Yadav ji, working as an associate professor in MIT Bangalore, he has completed his BE from University, BDT College of Engineering, MTech from GMIT Davangere, and PhD from Siddhartha Institute of Technology. He received the Best ASR Developer for Kannada Language in 2016 from IIT Madras, Best ASR Developer for Bihari Hindi Language on 2017 from IIT Madras, Research Contribution on 2022 at NMIT Bangalore, Karnataka. He has been working as a Doctoral Advisory Committee MSIS MAHE Manipal, Karnataka from 2021. He has published many papers in reputed journals. We are honored to have you with us today, sir, to share your knowledge. Thank you.
Good afternoon to all of you. Thank you so much for the introduction, ma'am. So today I'm going to talk about a concept called speech enhancement under uncontrolled environment. So this is my topic, which I'm going to explain briefly about what is meant by speech enhancement under real-time conditions and how it will be used for various types of other speech processing applications. So this is my outline of the presentation. Initially, I am going to talk about the brief introduction about speech as well as speech processing and its applications. Afterwards, I am going to concentrate mainly on speech enhancement. What is meant by speech enhancement, and how we are going to enhance the degraded speech under real-time scenario. Issues in speech enhancement. What are all the important issues are there, and why we need to consider the domain of speech enhancement for our research. After that, I am going to consider the motivation. What are all the important motivations are there in order to carry out research in the domain of speech enhancement. After that, types of degradations. What are all the important types of degradations are there? How the speech is going to be degraded by various types of noises. So that is called as what? The types of degradation. And the most widely used or common approaches for speech enhancement. How we are going to enhance the degraded speech data using various techniques. So that is going to be described in this particular point. Once we consider important techniques for speech enhancement under degraded conditions, how we are going to evaluate the performance of those techniques. So that includes the performance evaluation metrics. Next, I am going to talk about speech databases for the research. So once we wanted to carry out the research in the domain of speech enhancement, what are all the important databases are available? Open source databases are available to carry out the research. That I am going to speak about the speech databases for the research. Next is, what is the role of speech enhancement in other speech processing applications such as automatic speech recognition system, speech encoding, voice activity detection, speaker recognition, speaker verification, speaker identification and all. Next, what are the future horizons are there in the domain of speech enhancement? And finally, I am going to show some demonstrations of real-time speech enhancement, and finally I am going to conclude the entire presentation. So this is my total presentation outline. So the first one is speech. What is meant by speech? Speech is one of the most important types of communication among the human beings. Next is, what are all the important applications of speech processing? Many applications are there. In that, most widely used application is ASR. Have you heard the word ASR? That is automatic speech recognition. Automatic speech recognition is an amalgamation of speech to text as well as text to speech. So that is combinedly we can call it as what? Automatic speech recognition system. Next one is speech coding. It is a process of coding the speech signals using lower data rates. That is called as what? Speech coding. That is also one of the important types of applications of speech processing. Next is voice activity detection. So as the name itself indicates that voice activity detection is an abbreviation, I mean to say the acronym of VAD, which is a process of detecting the active regions of speech signal in the degraded speech data. So that is also one of the important applications of speech processing. The next one is speaker recognition. So as the name itself indicates that once again, it is a process of recognizing the speaker. So that is known as what? Speaker recognition. Under speaker recognition, you can see speaker verification as well as speaker identification. And the last one is speech enhancement. So this application we are going to concentrate over here. That is known as what? Speech enhancement. So here we are going to enhancing the quality and intelligibility of degraded speech, and that process is called as what? Speech enhancement. Now we shall concentrate only on speech enhancement. Many applications are there in speech processing. Under that we are going to concentrate only on speech enhancement. So what is meant by speech enhancement? Speech enhancement is a process of enhancing the quality as well as intelligibility of degraded speech. Say for example, I am speaking in a quiet environment. Say for example, it is a lab environment. My voice is not added with any types of noises. If you speak in train station or bus station or market, your voice will be added with various types of background noises. So your voice is a clean speech and noise is going to be added to that clean speech, and finally we will get the noisy speech. Now our aim is to enhance that noisy speech in order to provide a clarity in the communication. So that is our motto in speech enhancement. This particular pictorial representation shows how we are going to do speech enhancement under real-time scenario. Here you can see this is a clean speech which is uttered by a single channel speaker, that is represented by X of n, and the noise model, it might be train noise, station noise, babble noise, multi-speaker environment, any types of noise, that is represented by S of n. So X of n plus S of n is always equal to Y of n. That is called as what? A noisy speech. And our aim is to suppress these types of noises in the degraded speech data. So that's why I'm going to give this input speech data, I mean to say this speech data to the algorithm as an input. So this algorithm is going to enhance that degraded speech data, and finally it will give the reconstructed speech. That is called as what? A clean speech. That clean speech is approximately equal to your original speech. So that's why it is represented as X cap of n. X cap of n is approximately equal to your clean speech. So this is for stored database representation. Then how we are going to consider this scenario for real time world environment or scenario? That is a challenging task. So this is about speech enhancement. Procedural steps are the fundamental scenario of speech enhancement. Next is, once we give the input speech data, noisy speech data to speech enhancement algorithm, how we are going to get the output, how it will be looking like. Just assume that this is a clean speech signal. Here you can see this is the active regions of clean speech which is present over here. Now this clean speech is added by various types of noises. Once the noise is added to the clean speech signal, then it will be looking like this way. By seeing this waveform, we came to know that in this part there is a noise. In this part there is a noise. Here also there is a noise. Now our challenge is to minimize those types of noises in the degraded speech data. Once we apply the algorithm to this particular noisy speech data, definitely we will get the output like this way. So now you can see the first figure as well as the third figure, they are approximately equal with each other. So our aim is to enhance the degraded speech data. Our aim is to enhance the quality and intelligibility of degraded speech sound. So that procedure is called as what? Speech enhancement. Next is, what are all the issues are there in speech enhancement? Why we need to consider this domain as a research topic? The first one is quality of speech. So it is very difficult to improve the quality of degraded speech because in the real world scenario, clean speech will be added by various types of noises. So minimizing various types of noises is a tedious task or a challenging task to remove those types of noises. So we need to develop an algorithm in such a way that it has to remove various types of noises and it has to enhance the quality of speech. So that is one of the important issue in the domain of speech enhancement, that is called as what? Enhancing the quality of speech. Next is intelligibility. Intelligibility means in the presence of noise, how the sound is audible. So that is called as what? Intelligibility of speech. So that is also one of the issue in domain of speech enhancement, how we are going to improve the intelligibility of degraded speech sound by applying speech enhancement algorithms. Next is noise variabilities. So in the real world scenario, many types of noises are there. So developing a speech enhancement algorithm for various types of noise is a challenging task because noise is continuously vary with respect to time. Rapidly, it will change its characteristics, spectral characteristics over a period of time. So how to develop an algorithm for those types of noises which are changing their characteristics is a challenging task. So that is also one of the important issue in speech enhancement. Next is non-stationary noise. So non-stationary noise, how to handle these types of noises? Non-stationary noise means a noise which is going to change its spectral characteristics rapidly over a period of time. How to handle those types of noises? So you can take this part as a research work and you can develop a speech enhancement algorithm and you can remove various types of noises and you can write a thesis on this particular topic also. Next one is speech distortion. I will give a best example for this. What is meant by speech distortion? It is very simple. Say for example, I am going to consider a spectral subtraction algorithm. In the spectral subtraction algorithm, what we are going to do is, we are going to set a particular threshold. In that threshold, if the signal is greater than the threshold, then that will be considered as a speech. Otherwise, if it is less than the threshold, then it will be considered as noise. Now we need to keep or set a threshold in such a way that we have to remove significant amount of noise from the degraded speech data. If we are keeping higher threshold or aggressive threshold, then we may lose some speech components from the degraded speech data. So handling this particular point is very, very difficult. We have to keep the threshold in such a way that we have to remove only significant amount of noise from the degraded speech data. If you keep higher value of threshold, then it will take the speech component along with the noise components. There we will lose the quality as well as intelligibility. So we have to keep in mind that while developing a speech enhancement algorithm, we have to keep a threshold in such a way that it has to remove significant amount of noise without losing any speech components. So that is also one of the important issues in the domain of speech enhancement. Next is motivation. Why we need to consider this particular domain as research? Why speech enhancement matters? First one is communication clarity. We need to provide a clarity for a telecommunication systems. How to do that? It is very simple. We need to pre-process the input speech data. Say for example, you are going to consider the telecommunication systems. A talker as well as listener will be there. Both are talking in a real-time environment. So whatever he is going to speak in the real world scenario, that spoken words should be audible to or listened by a listener properly. If some amount of noises will be added to that particular speaker's speech, then it is very difficult to understand what he has spoken. So we need to provide a clarity in the communication by deploying the speech enhancement algorithms in telecommunication systems. Then only we can achieve 100% communication. Otherwise, the communication will be lost. So that is also one of the important matter which we need to consider as a motivation in the domain of speech enhancement. Coming to auditory assistance devices. So here also basically hearing aids as well as auditory assistance devices. If you deploy the speech enhancement algorithms in hearing aid applications, definitely we can achieve very good communication between two auditory devices, speakers as well as listeners. Next one is automatic speech recognition systems. So when I was working with SIT Tumkur, I used to build end-to-end speech recognition systems, automatic speech recognition systems. That project is a development of spoken query systems for Kannada language to provide real-time agricultural commodity prices and weather information in Kannada language. That was a project funded by Government of India. There I have developed an end-to-end spoken query system. That spoken query system enables the farmer to get the real-time agricultural commodity prices as well as weather information in Kannada language. Initially, I have developed a system for noisy speech data, and I came across a huge amount of order rate. Order rate means larger the order rate, lesser the performance of the system. Then I thought that we have to develop a speech enhancement algorithm in such a way that it has to remove various types of noises in the degraded speech data. Then we have developed a speech enhancement algorithm, and we have integrated that speech enhancement algorithm in spoken query system. Then we have removed various types of noises in the degraded speech data, and we have developed once again the ASR models, automatic speech recognition models, and we built a system, end-to-end system, and we found that a greater accuracy of speech recognition. So that's why deploying a speech enhancement algorithm in the automatic speech recognition system improves a greater performance. So that's why we need to consider the speech enhancement domain. Next is voice biometrics. Nowadays, the people are replacing the iris authentication system, fingerprint based authentication system, face based authentication system by the voice biometrics. So if you deploy the speech enhancement algorithms in voice biometrics, definitely we can achieve 100% authentication in the systems. So that is also one of the important advantages of speech enhancement in the domain of voice biometrics. Next is human-computer interaction. As I told you now, we have developed one spoken query system which is going to give the agricultural commodity prices as well as weather information in Kannada language. That is a human-computer interaction. There also, if you integrate the speech enhancement algorithm, you can achieve a greater performance. So speech enhancement, by seeing all these motivations, you can easily say that speech enhancement is a fundamental step for all other speech processing applications. You can use speech enhancement in voice activity detection, you can use speech enhancement in speech encoding, you can use speech enhancement in automatic speech recognitions, you can use speech enhancement in speaker recognition, speech recognition, everywhere, because all the applications are operated under real-time world scenario. In the real-time world scenario, the speech will be added by various types of noises. So in order to remove those types of noises, speech enhancement algorithm is very much essential. So that's why we can say that speech enhancement is a fundamental step for all other speech processing applications. Next one is types of degradation. What are all the different types of noises are available? Those are, the first one is the background noise. Background noise means you can consider train noise, station noise, babble noise, street noise, arm noise, vocal noise. These are all the important types of background noises. Second one is reverberation. If you are speaking in a larger auditorium or larger room, you will listen an echo of your sound. That is called as what? A reverberation. There is a delay in the original speech data. That can be called a reverberation. That is also acting as a background noise for the speech data. Third one is non-stationary noise. Handling non-stationary noise is very difficult because their spectral characteristics will be rapidly changing over the time. So if the spectral characteristics are rapidly changing over the time means it is very difficult to handle those types of characteristics for a speech enhancement algorithm. So we need to look into the characteristics in such a way that it has to remove significant amount of noises from the degraded speech data. And the last one is distortion. What is meant by distortion? As I told you earlier, we need to keep a threshold in such a way that it has to remove only some amount of noise from the degraded speech data. If you keep aggressive factor of threshold, then it will remove speech component along with the noise. That process is called as what? Distortion. It is distorting the speech component. So that's why you can call it as what? Distortion noise. So these are all the important types of noises are available in the real world scenario. Now our task is very tedious to develop a speech enhancement algorithm to remove any of these types of noises. It is very difficult to remove all these types of noises. None of the researchers have developed an algorithm that removes these types of noises. Some of the algorithms will work for some of the types of noises. Okay. Nowadays, the people are working on deep neural networks. Those neural networks are going to remove significantly these types of noises, background noise as well as non-stationary and incorporation. Still, the people are working on this one, distortion. How to remove the noise without distorting the speech components. That is very, very important area. Next is, I am going to just consider three important algorithms, that is common approaches for speech enhancement. Those are, the first one is spectral subtraction, second one is inner filtering, and third one is deep learning techniques. We shall see one by one how they are going to perform for various types of noises. The first one is spectral subtraction. It is most widely used, commonly used speech enhancement algorithm. So what all the steps are there in spectral subtraction algorithm? First one is framing. Framing means if you collect the speech data under real-time conditions, then it will be in time domain. Correct now? So if it is in time domain, then we need to process the speech data in frequency domain. So that's why what we are going to do is we are going to sample it. We are going to segment it. That process is called as what? A framing. Okay, framing is a process of segmenting a speech signal into several samples. Each frame will be having a duration of 20 to 25 milliseconds. Why we need to consider only 20 to 25 milliseconds means the vocal tract characteristics of each person will be a constant in that particular duration. So that's why we need to consider a framing for a duration of 20 to 25 milliseconds. We can't able to take 15 milliseconds, no. Because the characteristics will be changed for 15 milliseconds. We need to consider only 20 to 25 milliseconds. And that process is called as what? Framing. The next step is windowing. Why we need to do windowing? It is very simple. In order to minimize the spectral leakage and to remove the artifacts in the framed signal, we are going to perform the windowing. Once the windowing process is done, then we need to consider FFT. What it will do? It is going to convert the time domain signal into frequency domain signal. FFT is going to be considered for the entire signal, that is frequency and fast Fourier transform, which is going to convert the time domain signal into frequency domain signal. Once the signal is converted into frequency domain, then we need to estimate the noise in the degraded speech data. How to estimate the noise? It is very simple. We are going to keep some threshold and we are going to make a condition that if the speech signal is greater than the threshold, then there is a speech component, otherwise noise components are there. From that condition, we are going to estimate the noise. Once it is estimated, then we are going to subtract the estimated noise from the degraded speech data. Degraded speech data consisting of what? Clean speech signal as well as noise minus estimated noise. So noise will be cancelled and only speech components you will get. So that is called as what? Spectral subtraction. Spectrally you are going to subtract the degraded speech data as well as the noise estimated value. And finally, we are going to consider one more step, that is called as what? Off-wave rectification. Spectrally subtracted values will be having some negative values. Those values will be set to 0 because those negative values will be having negligible information, that will be set to 0 to minimize the complexity of computation. And finally, we are going to reconstruct the enhancer speech signal by using overlap R method. So these are all the procedural steps which comes under the spectral subtraction algorithm. Now, what are all the important advantages of this spectral subtraction algorithm? The first one is simplicity. It is very simple to analyze. It is very simple to deploy. Okay. Next one is real-time processing. We can also use this algorithm for real-time processing the degraded speech data under real-world scenario. The next one is no need of training data. Here, no need to give large amount of data as we give for DNA, right? Deep neural networks. Here, no need to give large amount of training data as well as test data. Just give a simple speech wave file and you will get an output file. Effective for stationary noise. Stationary noise means a noise which is not going to change its spectral characteristics over a period of time. For those types of noises, it will work better. And it will work better for only the high level SNR conditions. High level SNR condition means, say for example, SNR of a speech signal is equal to 15 dB. So the strength of the signal is very huge and noise will be very less. If you consider SNR is equal to minus 5 dB, the strength of the signal is very less and noise will be more. So this algorithm will work better for 10 dB SNR, 15 dB SNR. If you apply this algorithm for minus 3 dB, minus 5 dB, no, it will not work. It will give speech distortion. It will give peaks. You can't able to you can't able to listen that voice or the speech sound. So that is the major disadvantage of this particular speech enhancement algorithm. It will not work for lesser SNR conditions. It will work for only the medium or high SNR conditions. What are the limitations? Over attenuation of speech. As I told you earlier, if you consider negative SNRs or 0 dB SNRs, it will not work. It will lose some amount of speech components along with the noise. Difficulty with dynamic environments. So it is going to assume that the noise is stationary. That means to say, noise is not going to change its spectral characteristics over the time. So that is the major disadvantage of spectral subtraction algorithm. Ineffectiveness in low SNR conditions. As I told you earlier, if you consider minus 5 dB SNR, it will not work. Speech distortion will occur. So that is also one of the important types of noise. So nothing you will gain. So these are all the important disadvantages of the spectral subtraction. The next one is Wiener filtering. This is another method. In the initial step, we have seen the spectral subtraction algorithm for speech enhancement. The next one is Wiener filtering, that is a statistical estimator. It is going to estimate the noise based on the time frequency smoothing factors. Here also we are going to consider the framing, nothing but it is a process of segmenting the speech signals, and windowing. We need to minimize the spectral leakage as well as remove the artifacts. That's why we need to use the windowing procedure. Then we need to apply STFT. It is just like a FFT, but here we are going to apply the FFT for short duration frames. That is called as what? Short time Fourier transform. In FFT, we will apply the Fourier transform for entire signal. Here we will apply the FFT for short duration frames. As I told you earlier, framing is nothing but what? It is a process of segmenting the signal for 20 to 25 milliseconds. For 20 to 25 millisecond frame, we are going to apply the FFT. So that is called as what? STFT. Once we done the STFT, then we need to calculate the value of power spectral density. Power spectral density for clean speech signal as well as noise model. Then we will obtain the gain of a Wiener filter, that is obtained by considering a function called gain of f comma t is equal to clean speech power spectral density by clean speech power spectral density plus noise power spectral density. Once we calculated the value of gain, then that should be multiplied with the degraded speech spectrum. Then finally we will get the enhanced speech signal. So that is present over here. Now you can see the gain of f comma t is multiplied with noisy speech spectrum, and finally we will get enhanced speech spectrum. And finally, to reconstruct the signal as well as to remove the isolated peaks, we are going to consider a procedure called overlap OR method, and finally we are going to consider the reconstruction of an original speech. So this is, at this step we are going to get the enhanced speech. So this is a procedural steps which are mainly related with the Wiener filtering. Now, what are all the important advantages of Wiener filtering? Preservation of speech characteristics. Here, speech components will not be lost. Here, we are going to keep a threshold in such a way that significant amount of noise will be reduced. Speech components will be preserved as it is. That is the major advantage of Wiener filtering compared to the spectral subtraction algorithm. Applicable to various noise models. You can consider train noise, station noise, babble noise and all. Effective in medium SNR conditions. It will work for 0 dB, 5 dB, 10 dB, 15 dB SNR conditions. It will not work for negative SNRs. I mean to say minus 3 dB, minus 5 dB, minus 10 dB. No, it will not work. Next is the limitations. What is the limitation? As I told you, it is very difficult to implement for highly non-stationary environments. A noise which is going to change its characteristics rapidly over the time, for those types of noises it is very difficult to work. Complexity and computational cost. For deployment in other speech processing applications, it is very difficult to deploy because the cost is very huge. And it is very sensitive to mismatched errors between the clean speech signal as well as the noise models. The last one is difficulty in low SNR conditions. It will not work for negative SNRs. So that's why the people are moving for the deep neural networks. Next we are going to study that. There is speech enhancement using deep neural networks. Here also some of the steps are there. First and foremost is huge amount of data we need to give for learning the neural networks. So first step is dataset preparation. We need to prepare the dataset in such a way that we have to train the model as well as test the model. Say for example, you are having 100% amount of data means we need to consider 90% of the data for training, 10% of the data for testing. So that is the first step in speech enhancement using deep neural networks. Once we consider or once we prepare the data, then we need to extract the features from the speech signal. So what are all the feature extraction techniques are available? Those are this one, STFT as well as MFCC. You can use any of the techniques, feature extraction techniques. STFT will be applied for what? Converting from time domain to frequency domain. MFCC is going to give the information about pitch, period as well as the frequency information. So these are all the important techniques that we have to use for extracting the features of the speech signal. Next is, once we prepare the dataset, once we extract the quotients of the features of speech data, then we need to select the network architecture. So usually the people will use feed forward network architectures or recurrent neural networks. CNNs are mainly concerned with computer vision algorithms as well as image processing. RNNs are mainly concerned with signal processing. In that speech processing and its applications, the people are using the recurrent neural networks. So we need to select recurrent neural network. In that we are going to apply the input layers as well as output layers and the hidden layers. The next one is we need to select the input layers as well as output layers. What is the necessity of using E&CE means it is going to give the optimized output for a multiple input features. So here we are going to design the input layer that is going to accept the features from the noisy speech data. Output layer is going to produce the enhanced speech data. In between the input layer as well as output layer, neurons will be there. Those are called as what? Hidden layers. We need to select them, how many number of hidden layers must be there. DNN, structure of DNN will be looking like this way. Larger amount of input layers, smaller amount of output layer. It is going to capture the variations of speech signal from the input layers, and the output of input layer will be given as input to the hidden layers, and hidden layer will give the output of hidden layer will be given as input to the output layer, and output layer is going to produce the enhanced speech data. So that is the way to obtain the reconstructed signal from the deep neural networks. Next is loss function. So loss function is nothing but what? If any errors have been occurred in between the input layer as well as output layer, then we need to follow a procedure called backward error propagation. So whatever the output we got, that is not correct, that is not matching with the test input data. So that's why we need to go back to the input layer and we need to adjust the weights. Whatever the weights which are adjusted initially, we need to adjust the weight, and we need to repeat the procedure, and we need to get the output through the output layers, and we need to match that output to the input test data. If it is matching, then we can easily say that it is 100% correct. Otherwise, MSC, that is mean squared error, will take back that output to the input layers, and it will adjust the weights once again, and it will give the output. So, in order to do the backward error propagation procedure, we need to consider one loss function, that is called as what? Mean squared error. Finally, once you decide all these things, finally we need to train the model using 80% of the speech, that is clean speech as well as the noisy speech. And finally, once the model is trained, then we are going to test the system. Once the entire model is trained, then we need to input a test speech data. If you input the test speech data, then it has to reconstruct the noisy speech data, that is known as what? Original speech data. Okay, you are going to train the model. Once the model is trained, then I am going to give a noisy speech data as an input to this trained model. Then it will pre-process that data and it will give the enhanced speech data. So that is the beauty of deep neural networks. So usually deep neural networks will work for all types of noises, all types of listener levels. So that's why people are using, nowadays the people are using deep neural networks rather than conventional speech enhancement algorithms like peanut filtering or spectral subtraction algorithms. So that is about the procedural steps involved in speech enhancement using deep neural networks. What are the advantages of DNNs? Adaptability to complex patterns. As I told you earlier, if you consider any types of noises, it will give pre-processed speech data because the machine has been learned for various types of noises. So that's why it will remove various types of noises and it will give the enhanced or reconstructed speech data. So that's why it is very adaptable to various types of noises. We can easily improve the speech quality as well as intelligibility using the deep neural networks, and best suitable for deep or noisy or low SNR conditions. It can be work for high SNR conditions, mid SNR conditions, low SNR conditions or negative SNR conditions also. Deep neural networks. What are the limitations? Limitation is data dependency. We have to provide huge amount of data for training as well as testing. That is a major difficulty with respect to deep neural networks. For spectral subtraction and peanut filtering, we need to consider only small amount of data, one speech file, it will give the output. But here, huge amount of data in terms of 60 hours, 30 hours of speech data we need to give as an input to the deep neural network. Then only it will learn everything, every types of noises. Then only it will give the output in a correct way, otherwise it will not give. So that is a major drawback in deep neural networks. That is data dependency. Computational complexity. So it involves huge amount of linear algebra as well as the mathematics. And the cost. Deployment of speech enhancement using DNN in any other speech processing applications is very huge amount of cost. It requires large amount of cost. Say for example, if you really want to learn the machine for speech enhancement, then we need to procure the GPUs. Okay, it requires large amount of money. So deployment of speech enhancement algorithm in any other speech processing applications requires the cost, more amount of cost. Now, just assume that we have developed some speech enhancement algorithms. Then how we are going to evaluate their performance? What are the important metrics are available to evaluate the performance of speech enhancement algorithm? The first one is objective metrics as well as subjective metrics. There are two types of metrics are there. The first one is objective metrics as well as subjective metrics. In the objective metrics, two important evaluation metrics are there. The first one is speech quality evaluation, speech intelligibility evaluation. Speech quality is nothing but what? Overall quality of speech and how it is audible. That is called as what? Quality. Intelligibility means in the presence of noise, how it is audible. That is called as what? Intelligibility. For speech quality evaluation, three metrics are there. Three to five metrics are there. For simplicity, I have taken only three metrics. That is mean signal to noise ratio, segmental SNR, that is segmental signal to noise ratio. The last one is perceptual evaluation of speech quality. Most of the researchers in the domain of speech processing will use these three. especially this one, perceptual evaluation of speech quality, because this metric exactly mimics the perception of human ears. So that's why PEST is most widely used objective metrics for evaluating the performance of speech enhancement algorithms. Coming to intelligibility evaluation, the first one is normalized coherence metric, sentence intelligibility index, that is abbreviated as SII, and third one is coherence based speech intelligibility index. This is most widely used. Once again, it is going to exactly mimics the perception of human ears. So that's why the people will use this metric for evaluating the speech intelligibility of a speech enhancement algorithm. Coming to subjective metrics, listening tests or mean opinion scores. It is very simple. I am going to consider 20 listeners in a quiet environment or lab environment. I am going to play the speech sounds. They will listen and they will give a score in a scale of 1 to 5. They will listen the sound and they will score. They will give a score 3 out of 5, 2 out of 5. There will be a bias there. So most of the researchers will not use this metric because bias conditions will occur. So that's why people will go for speech quality evaluation or speech intelligibility evaluation. If you develop any of the technique, please remember we have to use at least 2 to 3 metrics. For some of the metrics it will work. For some of the metrics it will not work. So that's why we need to evaluate the performance of a particular speech enhancement algorithm by considering 2 to 3 metrics at least. Then we can draw the conclusion. Yes, this algorithm is working better for this particular noise, this particular SR level. So that's why it's better to use both the metrics. 2 from this, 1 or 2 from this. Okay, don't go for this. I think so. This is not required. So these are all the performance metrics to evaluate the performance of a developed speech enhancement algorithms. If you really want to carry out a research in the domain of speech enhancement, then please go through these databases. These are openly available speech databases, open source databases. That is Noisius, Timid speech database, Aurora is there, WST, that is Wall Street Journal speech database, Aurora 2, that is the extended version of Aurora, and LibriSpeech is there, Kind4 speech database is there. All the speech databases are English speech databases. In those databases, English speech sentences will be there. Those speech sentences will be added by various types of noises and they have produced the noisy speech data. Then we need to consider those noisy speech data and we need to develop a speech enhancement algorithm and we need to test that algorithm using those metrics. So these are all the available databases for the research. Next is, what is the role of speech enhancement in automatic speech recognition system? So you can see here the role of speech enhancement is very huge. This is one of our work which has been published in Human Journal. So the first column shows the phoneme levels. These are all the important acoustic modeling phoneme levels in the domain of automatic speech recognition system. Now you can see these are all the word error rates which were obtained for noisy speech data. Nothing to say. We have developed automatic speech recognition models using all these speech recognition toolkit for noisy speech data and we got a word error rate of 10.80. I will mention that lesser the word error rate, more the accuracy of system. We got 10.80% word error rate. Now we thought that we can easily minimize this word error rate by removing various types of noises. So that's why we have developed a speech enhancement algorithm and we have integrated that speech enhancement algorithm in automatic speech recognition models. And we have executed once again and finally we got a word error rate of 9.60. Now you can see there is a difference between this and this. How much? 1.2%. 1.2% of accuracy of speech recognition has been improved. Further, we thought that further we can minimize the various types of noises. So that's why we have developed a statistical estimator speech enhancement algorithm and we have applied once again on the noisy speech data and finally we got 9.01% word error rate. Now please look into this value as well as this value. Almost 1.8% of accuracy of speech recognition has been improved. So now we can easily say that the role of speech enhancement is very huge in any other speech processing applications. Correct? No? Because ASR is a speech processing application. Automatic speech recognition. Speech recognition is an application of speech processing. So in that we are going to use the speech enhancement as a fundamental step. We have removed various types of noises, and finally we got huge amount of accuracy. So that is known as what? The role of speech enhancement in the domain of automatic speech recognition system. Coming to the role of speech enhancement in speech coding. So as I told you earlier, speech coding is a process of coding the speech signals using lower data rates. Our aim is to send the data through a channel using lower data rates, correct? No? So here you can see these are the different panels which are showing over here. This is called as what? Clean speech signal. Here you can see there is no noise over here, only speech components are there. And this clean speech is added by a restaurant noise at 10 dB SLR. If you add a noise, then you can see here noise is there, correct? No? Some amount of noise is there. Now I am going to encode this particular noisy speech data. Encode means what? We are going to just compress the speech data using lower data rates, and we are going to transmit the speech signal. If you compress that, this is the compressed signal. The quality of the speech signal has been reduced because it is compressed. Once it is compressed, then it was audible but not up to the mark due to the presence of background noises. We thought that we have to intervene the speech enhancement algorithms in this particular areas. So that's why we have developed speech enhancement algorithms, and we have enhanced the degraded areas. Now you can see some amount of noise has been reduced over here, correct? Here you can see noise is there, less amount of noise is there, here also, here also. These are the three speech enhancement algorithms which we have developed, and we have applied those three algorithms for this noisy speech data, and we got enhanced speech data over here. Correct? Next is what we have done is I have considered the enhanced speech data and I have encoded using LPC. Finally, we got this signal. Here you can see, you just compare this as well as this. Significant amount of noise has been reduced. At the same time, we can easily audible the speech sound. So that's why the role of speech enhancement in the domain of encoding plays a vital role. Correct? Here you can see third panel, that is C as well as panel H. Noise is removed over here compared to this one here also. So that's why speech enhancement plays a fundamental role in speech encoding also. This is the spectrogram representation. Here you can see from this you can easily identify the regions. This is clean speech data, noisy speech data, noisy encoded speech data, enhanced encoded speech data. Here you can see more amount of red as well as yellow colored pictures are there. Here you can see less amount of yellow colored, I mean to say red colored pictures are there. So now you can see this as well, compare this one as well as this one, they are approximately equal provided it is encoded. That's all. Once it is encoded, enhanced, then we can easily listen that particular speech, and quality and intelligibility of that particular speech has been improved. So that's why it is playing a vital role in the domain of speech encoding also. Coming to voice activity detection. So here you can see this is a clean speech signal. VAD is nothing but what? It is a process of detecting the active regions of speech signal. So this is a clean speech signal, and the active regions of clean speech signal is represented by a red colored box. Now just assume that this clean speech signal is degraded by a restaurant noise at 10 dB SLR. Now you can see it is showing lesser red color area over here compared to this due to the presence of noise. Correct? Now I need to develop the speech enhancement algorithm in such a way that it has to remove this noise and this should become to this place. We have developed a speech enhancement algorithm and we have applied an algorithm to this noisy speech data, and we have enhanced it over here. Here you can see noise has been removed and it has been widened. Correct? So this is approximately equal to this. You can see this is called as what? A reconstructed signal or enhanced speech signal that should be approximately equal to your clean speech signal. So that's why speech enhancement is playing a good role in the domain of voice activity detection also. Now, future horizons of speech enhancement. If you really want to carry out research in the domain of speech enhancement, then you can consider these following steps. Those are deep learning advancements. You can develop a speech enhancement algorithm using deep learning techniques, and you can develop an algorithm in such a way that you are going to pre-process the real-time data with less amount of delay. And nowadays the people are using these types of techniques. Usually what we will do is we will consider only the manipulated information of a speech signal, and we will pre-process the data, and we will construct a original speech. Nowadays the people are using manipulated as well as phase information. So that is known as what? Phase away speech enhancement. And the amalgamation of speech enhancement and other speech processing applications. As I demonstrated in the previous slides, amalgamation means the combination of speech enhancement and other speech processing applications. Say for example, speech enhancement plus ASR, speech enhancement plus encoding, speech enhancement plus WAD, speech enhancement plus speaker recognition. So these are all the different types of applications are there, but make sure that speech enhancement will play a fundamental role for other speech processing applications. IoT integration. We can easily deploy the speech enhancement algorithms in Internet of Things applications. Say for example, home appliances applications, as well as medical applications, banking applications, military applications. Everywhere we can use hearing aid applications. Everywhere we can use the speech enhancement algorithms. I'll just play this particular video. You'll come to know what exactly the speech enhancement. Please listen to this. Speakers are there, right? I'll play this one. Just see.
They know nothing about us, but we shall have to talk to him. Well, we know now. He was only doing his job. They built the ladder. The legal process could last weeks. All the way to Yadav.
It needs to be sorted out by Easter. Nowadays, it's workers who matter. He is young, but not too young. I played well on Saturday and pick up today. It will also take evidence from consumers.
Yes. By seeing this demonstration, you came to know that I think so. This is an IC speech, which is presented over here in terms of earphones, and this filter speech. You can see here noise has been removed, and clearly it is audible. One more video will show.
Digital communication devices such as hearing aids, telephones, or voice-controlled systems are very often used in noisy environments. We now demonstrate the performance of a real-time speech enhancement algorithm in real-world noise. The common noise scenario is known to be a difficult scenario for speech enhancement. This is because of the non-stationarity of the noise and its speech-like characteristics. At the same time, babble is a noise type we are confronted with. For example, in a restaurant or at a cocktail party. The generalization to noise types that have not been seen during training is an important research question for deep learning-based speech enhancement approaches. For instance, the vacuum cleaner has not been part of the training set. Better generalization to unseen noise types can be achieved by using fluid speeches and by increasing the amount of training data. Here, we propose to combine the good generalization of traditional approaches with the power of neural networks by normalizing the input on an estimate of.
The advantage of deep learning-based speech enhancement methods is most obvious in non-stationary noise sources. This is because classic approaches without training are based on the assumption that the noise signal is more stationary than the speech signal. For this very reason, in a scenario like this, classic approach is not capable of distinguishing between speech onsets and the impulsive sounds of the bone. In contrast, deep learning-based techniques is capable of exploiting the different spectral characteristics of speech and noise for the improved noise reduction. For this very reason, the advantage of deep learning-based speech enhancement methods is most obvious in non-stationary noise sources, as we saw here.
So those are the two important demonstrations of speech enhancement under real-time conditions. We have developed some algorithms. Among those, I just wanted to demonstrate one of the algorithms. Real-time speech enhancement for stored speech database. I'm going to just run that code in front of you people. What it will do is, it is very simple. It will enhance the stored speech database. Say for example, I'm going to input 2 speech file simultaneously. It is going to enhance simultaneously. I'll just show that. What happened? Okay. So now you can see I'm going to input these speech wave files. Totally 2180 items are there. Those speech signals were degraded by various types of noises. I want to pre-process these speech wave files at a time. So I have written a code and I'm going to store those reconstructed or enhanced speech signals in this particular folder. Now I'm going to run this. Now you can see the files are enhancing over here. This is for stored speech database. Simultaneously, it will take the inputs in an array and it is going to enhance the speech signal, degraded speech signals. So this is one of the important examples. If you really want to consider a speech enhancement algorithm and if you really want to enhance the degraded speech data for a large amount of database, you can use this code. Okay. So this is for stored speech database. One more thing I just really want to show, the real-time speech database, speech enhancement. Okay. So this is for real-time input speech enhancement. Here what I am going to do is, I am going to give a real-time input speech data now only, and it is going to simultaneously pre-process the speech data. I'm going to run this one. I'm speaking in the presence of vocal noise. For example, my speech. Speaker is very near to this Yadav, that's why it is echoing. Hello. See, it is processing in a real time scenario. I hope all of you people understood this. This is called as what? Real time speech enhancement. If you consider this algorithm in station noise also or market noise also, it will pre-process that noise and it will give the reconstructed speech data. Whatever you are listening after my voice, that is called as what? The enhanced speech. Whatever you are seeing here, this is called as what? Input speech. And this is enhanced speech, which you are going to get. Is it okay? This is called as what? Real-time speech enhancement. See, there is a distortion for my speech also. You could observe that. That is called as what? Speech distortion. How to handle that? We need to keep a threshold in such a way that we should not lose my speech components. That is called as what? Real-time speech enhancement. So I'm going to conclude my session. Speech enhancement plays a vital role and it is an evolving field in the domain of telecommunication as well as automated speech recognition systems. And deep learning has shown a promising results in robustness of speech enhancement models. Finally, other speech processing applications performance can be improved by using the speech enhancement algorithms under uncontrolled environment. So that is my conclusion regarding this speech enhancement under uncontrolled environment. These are the references. Thank you so much for listening. Any queries?
Speech database.
Yes, madam, it is there. One website is there, openslr.org. There you can find plenty plenty of data sets for different languages. You can find Kannada language, Tamil, Telugu, Hindi, English. You can find openKSLR.org. Anything else? Okay, that's all from my side. Thank you so much. Thank you.
ಪಬ್ಲಿಕೇಶನ್ಸ್ ಏನಾದರೂ ಒಂದ್ಸಲ ಹೇಳೋ Q1 ಒಂದು 5 ನಿಮಿಷ.
Okay. Publications is, we need to, many things are there in publications actually.
Since he has published 21 Q1 journals.
Sir, it has taken around 10 years to do that one. Yes.
Per year is going to write.
Yeah, definitely. Per year we can able to publish. I'm telling you, publication is not just like a hotel management. Okay, in the morning we are going to invest, in the afternoon we are going to get a profit. No, it is not like that. It is a dedication of years together. We have to do a publication. I mean to say, if you really want to publish a paper for 2026, then you need to work from now, 2024 or 2025. Then only you will get a consistent publications. Otherwise, you can't able to get. Okay, we can't able to publish a paper for within a duration of 6 months or 8 months. No, it is not possible for people. If you want to publish scopus and all, you can in 2 months or 3 months, but it will take huge amount of time. Provided you have to provide, huge amount of dedication, determination, and you need to keep sufficient amount of time to do a publication in Q1. If you want to publish a paper for 2026, then you need to work from now only. For 2028, you need to work in 2026. Then only we can achieve very good number of publications. Coming to writing a research manuscript, it consisting of plenty of steps. So collaboration plays an important role, because if you consider a normal guidelines of a manuscript, it will be consisting of abstract, keywords, introduction, related work, and your core algorithm, performance evaluation, finally demonstration of results, conclusions. How many sections are there? Minimum 8 sections are there. At least you need 2 to 3 people to manage all these things, right? One person is concentrating on core of the algorithm, means another person should have a concentration on how to write the manuscript. Another person should have a concentration on how to review the manuscript. So that's why collaboration plays a major role while writing a research manuscript. So coming to some people will adopt some procedure steps that I'm going to write first introduction, I'm going to write section 3, I'm going to write section 4. No, that is not the way. If you are writing a research manuscript, means you should write first abstract. Then only we can easily say that you are having plenty of knowledge in that particular domain. Writing an abstract is not an easy thing. We can convey the information in 10 pages, but we can't be able to convey the information in 6 lines or 7 lines. It is very, very difficult. If you are capable of writing an abstract for a particular paper, means you have to be intelligent in that particular domain. So many people are working on different types of fields. You have to mainly concentrate on, the first thing is introduction. Introduction plays a vital role. There you need to concentrate only on a brief introduction about your concept. That is very, very important. Don't elaborate it for 2 to 3 pages. No, not required. Only 2 to 3 paragraphs. Then comes related work. What we will do is, we will consider the papers which have been published in the year of 2001, 2002, 1997. No. We have to consider the research manuscripts which have been published 3 years ago, from 3 years ago to till date. We have to consider. Then only we come to know what are all the innovations have been done in that particular area. We need to consider those works, and we need to cite those works, what they have done, and what I am going to take from those papers. That matters a lot. Make a table in the related work, what they have done. Say for example, title of the paper. Then, what are the techniques they have used, what they have discussed, what they have included. In the techniques, what you are going to use, what the parameter you are going to use, take that parameter, and you need to write the relevance to the study at the end of the related work. What they have done, what I am going to do from that. At the end of the related work, we have to write the contributions to the work. What is your aim of the work? What is your objectives of the work? What you are going to contribute to your work compared to the previous literature. Then reviewer will come to know that exactly they are doing like this. Otherwise, reviewer will be in a dilemma. What they have done? He needs to search each and everything. Okay, that's why I am telling you, in the related work section, you have to write or you have to list the major contributions to that particular current work. Then you need to work on those contributions. 2 contributions are there, make it 2 sections. 3 contributions are there, make 3 sections. Then finally, we need to give the results as well as discussions. Results and discussions should be in a demonstrated way. We have to discuss each and everything rather than showing the pictures only. I have seen many manuscripts, they just put the diagrams, no explanations at all. No, we have to write in terms of words. If you are getting 1.20, why you are getting 1.20 compared to the previous literature? What exactly it is doing there? We need to give the clarification at that particular point. Then only reviewer and editor feels that yes, this is correct work compared to the previous literature. We have to accept that. We need to provide a clarity in the demonstrated results. Then we need to conclude the work. Conclusion means it should be always in line with the abstract. It should not go beyond the abstract. What you in the abstract, what you are going to tell is, you are going to tell what we are going to do. In the conclusion, what we have done. That's the way we need to write the research manuscript. In the abstract, we have to tell in present continuous tense. In the conclusion, we have to tell in past tense. That is the way to write the research manuscripts. Once you have completed everything, please keep your course, demonstrated videos or anything in GitHub or your personal websites. Give that link in the abstract. Then reviewer or editor will look into that. He will validate the work, whether really they have done or not. If he has validated that work, definitely there may be a chance of getting accepted in that particular journal. So that is the value added advantage for a particular manuscript. Please keep your work in your website or GitHub. So it is very authenticated towards the work. So that's all. Anything else, sir? Any questions, please?
One more thing.
Yes,
Whenever we start writing a manuscript, right?
Yes.
So whatever we write, it's going to be plagiarism.
Yes.
So any hint or any clue in how to write about the manuscript?
See, writing in an indirect way, that is another way of minimizing the plagiarism. Coming to the results, if you are representing the results in terms of values, try to put it in another way. Say for example, bar graph, bar chart, or in terms of figures. There, the entire table plagiarism can be minimized. So that is one way in terms of results as well as discussion part. Another way is that we have to write that. No other way for that. We can use AI tools also, but meaning will go. We will not get the exact meaning which I wanted to represent in our manuscript. So that is the one. Coming to the results as well as discussion, we can represent the values in terms of bar graphs and charts. So there we can easily minimize the plagiarism. Anything else? Okay, I hope this is, I personally believe that this might be helpful for you people who really wants to carry out their research in the domain of speech enhancement. If you really want to get any help, free to ask me. I'm there, and my guru is there. Nagaraj sir, he's always been an inspiration for me, always. In future also, he is my guru. So you can contact him. He's a resource person in the domain of speech processing and its applications. If you want any help, please contact us. Thank you so much.
Thank you for your valuable insights into the motivation, challenges in automatic speech recognition systems, common approaches of speech enhancement algorithms along with advantages and disadvantages, performance evaluation metrics in speech processing, the role of speech enhancement in speech encoding, voice activity detection, and how to publish papers in reputed journals. Now I would like to request Dr. Chandrasekhar M. Patil, Professor and Head of Department of E&CE, to hand over the token of appreciation to the resource person, Dr. Thimmaraja Yadav ji, Associate Professor from Nitte Meenakshi Institute of Technology, Bengaluru.
And also call his guru.